We're here today to talk about the Grafham Resilience Project. We won the Carbon Reduction Project of the Year for the British Construction Industry Awards. So today we're just going to go a little bit through that, what the project was all about, how we achieved the success, and try and give you some ideas for how we sort of attacked it and came out with the successful outcome. So my name's Craig Fisher, I'm the contracts manager for J.M. Bentley. We're the contractor for the project. This is my colleague Lewis Evans. He's the lead designer for the project. So we're going to look at why the project was conceived in the first place. Then we're going to move on to how we challenged, validated, and then actually implemented the solution. We're going to look at outcomes for customers. So the main thing with we're not just building for building's sake, but we're going to look at the outcomes and the final result for the customer and also the client. And as we said, we've called them success factors, just some little, there's 4 or 5 things that we think can become business as usual, and that might help other projects or businesses as going forward. So the key thing with this project, it provides resilience, and by that I mean it's clean water resilience. So this project provides clean water resilience for around 614,000 customers. That is around 15% of Anglian Water's supply chain. So quite a big area. As you can see the diagram over on the right there, it's quite a big area. Anglian is the driest region in the UK, where very little rainfall compared to the national average, and also it serves some of the largest growing areas in the UK as well, such as Cambridgeshire, Bedfordshire, Milton Keynes and Northampton. So we've got real challenges there. So this is aligning our goals with the client, and obviously we've tied in the UN sustainability goals there as well, and look to where we can match those goals up. It's really important for our client Anglian Water that we do this, and that was really integral in the success.
So, hello? Hello. Right, so I'm going to go into a little bit more detail about what the project actually was. This is a very simplified map of the water network. So you've got the towns such as Peterborough, Northampton, Huntingdon, Bedfordshire, Kettering, Corby, all supplied by one kind of integrated network. And there's kind of 3 key assets supplying clean water to the millions of people that live in this area. There's raw water reservoirs at Rutland Water, Grafham Water and Pittsford Water, shown by the blue circles. And essentially the goal of the project was that if Grafham Water Treatment Works, which supplied clean water for about 800,000 people, was to face a catastrophic incident like severe weather, like we've seen in the last couple of weeks, or a terrorist incident or a process failure, around 614,000 people would be out of water and have no clean water supply. So the original project conception was to build a new pipeline from a key point in the network to Grafham Water into a new reservoir and pumping station. So this pipeline would have been 36 kilometres long, 900 mil diameter, would have had to be built through a triple SI, would have had massive environmental impacts. So at the kind of inception of the project, we identified an opportunity to transfer water along an existing 50-year-old pipeline in the reverse direction. So this hadn't been done before. There's massive risk to customers by reversing mains from a water quality point of view and a customer pressure point of view. So we did a lot of network modelling, non-destructive testing, and finally a live flow trial live to around 400,000 customers. So this required more upfront investment to try and realise this opportunity. The final flow reversal trial, which is shown here, essentially reversed the flow in a strategic main supplying nearly 500,000 people live overnight, and we installed filters at the point of which customers received their water, did CCTV surveys to try and understand the condition of the pipe, to know we could reuse it as an asset. But the key thing is that it took a lot of initial investment to kind of pursue the opportunity. So the flow reversal trial, one night of trialling cost about £1 million as a kind of discrete activity. And the aim of that was to try and validate the fact we wouldn't need to build this new pipeline, which would save a lot of carbon and capital cost. So the final outcome of all that optioneering and going after this opportunity was that we halved the capital costs of the project and reduced the embodied carbon by about 62%. So that's about 17,000 embodied tons of carbon dioxide. So to enable us to transfer clean water about 65 kilometres along existing assets. So just to give you an idea of the scale, it's about 1,000 litres a second of treated water going straight to kind of customers' taps being reversed.
Okay, so not just once we got the big victory, which was the no-build solution, and then validating that solution, reusing existing assets, we carried on in that thought process to sort of take it into the build of the project. So this here, what we see, is the UK's largest precast clean water reservoir. So this is at the bottom end of Lewis's diagram, which I showed earlier. So straight from this tank, this goes to people's taps. So this was sort of the production line approach that we used, because these are all precast panels, precast columns, beams and roof panels. So you can set up that factory line approach, if you like, and production line, rather than a traditional construction project where you've got in situ concrete, a lot of embodied carbon there. You can gig yourself up, so you're receiving materials, putting the materials down, so it's getting that prefabrication and transferring it onto a site process. This does supply, so it stores 44 million litres of clean water. So that, to put in perspective, can supply the surrounding region for about 48 hours before we run out of water. So just taking that on a bit further, this is a connection into a live water main. So this here is 900mm diameter, so quite large connections. But again, we transferred that as a prefabricated piece. So this was built above ground and then dropped into position, because what you're under massive time constraints when you do it's called a line stop effectively. So we have to cut customer supplies off and have to be rezoned and supply from elsewhere in the network. We off memory, I think we had 12 hours to do that connection, which we were really up against it. So we did a number of dress rehearsals, actually bolting up, torquing up those joints and those bolts, just to prove to ourselves we could do it. And again, just taking that prefabrication, drop it in, job done effectively.
So this is a 3D model of the pumping station, which supplies the customers after the service reservoir, which Craig just showed. This is all designed in kind of a 3D environment, really made to try and incorporate safety and operability into our design. We use a software package called Revisto, which has got a Revit add-in, so you can walk around the asset as if you're physically operating it, operate valves. And that really kind of gave our client teams the confidence that we're building something that can be operated for the next 50 years and is kind of suitable for use. As well as the kind of 3D side, we also did an enormous amount of network modelling. So using big data from this entire network, supplying millions of people, crunching all that data to do virtual commissioning. So to understand, when we change this really large, complex network, what impact is that actually going to have on each customer and each reservoir in that network.
So worth just pointing out there, so Anglian Water, their existing model, if we want to call it that, they didn't know a great deal about the system, which to us came as a bit of a surprise. However, subsequent to this project, they now know that system like the back of their hand, and they can play different tunes on that network now, not just for this project, but they know they can take areas out of supply and rezone, and it's give Anglian Water a whole resilience in another aspect, really. So they can play different tunes on their network, which they wouldn't have been able to do previously. Just taking it back to community and customers again, so the site was opened by the Duke of Edinburgh. He's got a long-standing relationship with the area, and just giving back to the community as well. And just talking about the numbers that Lewis mentioned earlier, sort of 30 million reduction in capex and the massive 62% reduction in embodied carbon, that allowed Anglian Water to reinvest, and they reinvested that in some renewables, so solar panels and renewable energy, and also I'm informed that they maintained their low bills. So that sort of sums up what we were talking about the project. But these are sort of four key themes running through that we think, if they become business as usual in the industry and throughout business, we can really challenge and start to make a difference. So we've got the challenge in the norm, which is an obvious thing, but we need to be involved right at the outset to do that. I mean, this wasn't an easy win. We're sort of challenging the attitudes and behaviours of time-served client personnel. So that main that Lewis explained earlier, that ran in the current direction for over 50 years. So when the design and build contractor comes up and says, I think we can reverse that, Mr. Anglian Water. It's not something they're just going to say, yeah, okay, crack on and do that. So that took sort of 18 months of the project to do that and validate it, and then the trial that Lewis showed. So it's having a really open-minded client to actually jump on those opportunities and come on the journey with you. So it's not just collaboration, it's actually full integration with us. We did have a guy from Anglian Water, so it's not very collaborative, just Lewis and I sat here, but we did have a guy from Anglian Water, but quite topical. He's actually dealing with some of the issues they've had from the cold snap last week, so he's maintaining customer supplies. That's why he can't be with us today. So it's an ever-present issue, really.
So key for me really was the contract defining outcomes and not scope. Traditionally this would have been a pipeline project. You would have done a detailed design, a contractor would have come on to build the pipeline, done a bill of quantities, which you wouldn't have realised any of these savings if you'd used kind of a traditional procurement method. But because we're kind of part of a wider alliance and we're all aligned towards Anglian Water's business outcomes, we're able to kind of see those opportunities early on. Because if you get a contractor on a late stage just to build a pipeline, they're just going to build a pipeline for you effectively. So